Okay, let's look at reflecting the absolute value parent function over the x-axis. So I have my parent function y equals absolute value of x. Here's a partial table of values for the parent function, and here's a partial graph of y equals absolute value of x. Now, while we're exploring reflecting the absolute value parent function over the x-axis, we're also going to encounter some cases where the absolute value parent function is stretched or compressed. So I encourage you to watch my video on stretching and compressing the absolute value parent functions. The link to that video is in the description below. So let's get started by looking at y equals negative 1 times the absolute value of x. I'm going to look at this graph by plotting points. So let's get started. When I plug in negative 3 for x, the absolute value of negative 3 is positive 3, and negative 1 times positive 3 is negative 3. Likewise, with negative 2, I'm going to get the absolute value of negative 2 as positive 2 times negative 1 will be negative 2. And the same thing for negative 1, the output's going to be negative 1. When I plug in 0, the absolute value of 0 is 0, and negative 1 times 0 is 0. Absolute value of 1 is positive 1. Negative 1 times positive 1 is negative 1. And this table, using symmetry, we can fill out, or I think you pretty much see what's going on here. So now let's start plotting these points. I'm going to start at the vertex and then graph the right-hand branch of the absolute value function and then the left-hand branch of the absolute value function. So starting at the vertex of 0, 0, the next point on the right-hand branch is 1, negative 1, then 2, negative 2, and 3, negative 3. I was just taking those values directly from the table of values we completed a moment ago. So let's connect these up with a nice straight line here. And there is the right-hand branch of our absolute value function, y equals negative absolute value of x. So let's plot the points to the left. When x is negative 1, y is negative 1. When x is negative 2, y is negative 2. When x is negative 3, y is negative 3. And again, let's connect those up. The first thing you should notice about this graph is that this graph is reflected over the is the parent function reflected over the x-axis. These graphs are mirror images of each other if you imagine the mirror is the x-axis. So that's the main goal here is observing that when you multiply the absolute value function by a negative, you end up reflecting the absolute value function over the x-axis. Another thing, which is a similar observation we made in stretching and compressing, is that the slope of the right-hand branch is negative 1, which is the leading coefficient here in my function y equals negative absolute value of x. So I'm going to write the slope of the right-hand branch is negative 1, and the slope of the left-hand branch, you'll see, is positive 1. And if you want to see more examples of that, go watch the video on stretching and compressing absolute value functions, and that'll cover that. So now what I want you to do is plot points for the following function using a table of values, and then make observations about the transformation from the parent function to the image y equals negative 2 times the absolute value of x. Describe the transformations from the parent function and find the slope of the right-hand and the left-hand branch. And when you come back, I'll have that answer for you. Okay, I've completed my table of values and graph for y equals negative 2 times the absolute value of x. And what I've noticed is that y equals negative 2 times the absolute value of x is the graph of the parent function stretched vertically by a factor of 2 and then reflected over the x-axis. Again, if you watch the previous video, you understand the stretching and compressing, and the reflecting is the only new part here. This multiplying by a absolute value by a negative number. Now, if you keep doing several of these examples, what you'll notice is the following. If a is equal to negative 1, the graph of y equals a times the absolute value of x, or y equals negative absolute value of x, is the graph of the parent function reflected over the x-axis. That was this blue example, y equals negative absolute value of x. Now, if a is less than 0 and a is not equal to negative 1, the graph of y equals a times the absolute value of x is the graph of the parent function stretched or compressed by a factor of the absolute value of a and then reflected over the x-axis. We saw this in y equals -2 times the absolute value of x. It was stretched by a factor of 2 and reflected over the x-axis. The parent function was. Now, the key observation, which this is an observation we obtained from a previous video, is that if we're given y equals a times the absolute value of x, the slope of the right-hand branch is a and the slope of the left-hand branch is -a. Now I'm going to use this observation to graph y equals -1/3 times the absolute value of x, and then I'm going to use the observation on a to determine if it was stretched or compressed and reflected and all that good stuff. Okay, so I know the vertex is 0, 0 because this graph has not been translated horizontally or vertically. And I know the slope of the right-hand branch is -1/3, so I'm going to go over 3, 1, 2, 3, and down 1, because my slope of the right-hand branch is -1/3. My slope of the left-hand branch will be 1/3, which is -a. So I go left 1, 2, 3, down 1. Okay, just connect all this up with a straight line. And here is the graph of y equals -1/3 times the absolute value of x. Okay, and so what you should notice is that the graph of y equals -1/3 times the absolute value of x is the graph of the parent function compressed vertically by a factor of 1/3 and then reflected over the x-axis. Okay, based on how I just graphed y equals -1/3 times the absolute value of x, try to graph these three functions. Pause the video, graph the functions, describe the transformations from the parent functions, and when you come back, I'll have the answers posted to the screen. Okay, welcome back. Here are the three graphs as promised. As you'll notice, y equals -3 absolute value of x is the graph of y equals absolute value of x stretched vertically by a factor of 3 and then reflected over the x-axis. The slope of the right-hand branch is -3 and the slope of the left-hand branch is +3. Y equals -1/2 absolute value of x is the graph of y equals absolute value of x compressed vertically by a factor of 1/2 and then reflected over the x-axis. The slope of the right-hand branch is -1/2. The slope of the left-hand branch is, of course, 1/2. Y equals negative absolute value of x divided by 5 is the graph of y equals absolute value of x compressed vertically by a factor of 1/5 and then reflected over the x-axis. Let me know how you did on these questions in the comments section. Thank you for watching.